Very good morning to all of you. This is lecture 2 for this unit, that is the units and measurements. In the previous class, we have discussed about the definition of unit as well as the definition of measurement, and we have learnt about the various systems that we are using for measurement, and also we have derived the dimensional formula for various quantities. Now, there are some more important quantities whose dimensional formula should be known to you. So we will be first deriving some of the dimensional formula that you will be using in the applications of the dimensions. And then will be doing one application of the dimensions, that how we can use the dimensions to do up certain things and to apply them in certain concepts of physics to know the quantities in a better way. And without wasting any time, let's start it up. We need to find the dimensional formula of some angular quantities. Okay, and the first quantity is angle. So in the angular quantities, this angle dimensional formula should be known to you, and it is denoted by theta. Let me tell you this thing, that we have to remember these dimensional formula. All right, so whatever the dimensional formula that I am discussing with you, you have to remember them up. The final result should be known to you. So once you are in a practice and once you started using them in question, then automatically you will be learning them up. So just if you in case forget out, that's why I have given you this complete derivation, that how to obtain up. So if in case you forget in between the exams or while doing up the questions, you can easily derive them up by using the formula. So the procedure should be known to you, that how to derive. No one is going to ask you in the exam that how to derive these formulas actually. So you just should be knowing the final result, that the dimensional formula for this quantity is this. For force it is mlt minus 2, for velocity it is lt minus 1. So all these you must be knowing the final result, and that final result we'll be using when we'll be doing the applications of the dimension. So let's start with this. The dimensional formula for angle. The formula for angle theta is like this. Angle theta is arc length upon radius. So arc length is some type of length. Length of the arc is some type of length. There's a distance. And radius is also some type of length. So both must be having dimensional formula as L. So it can be written like this, L upon L. Because for arc length, the dimensional formula is L. For radius also, the dimensional formula is L. Why so? Because they are some kind of length. Both of this length, they get cancelled out and you are left with one only. So one is what? It is a constant. And I have told you that the constants, the numerical constants, I'm not talking about the physical constants. The physical constants, they may have some dimensional formula. The numerical constants like 1, 5, 10, 858, whatever be the numbers, numerical numbers, they are dimensionless. It means that they are having a dimensional formula as M0, L0, T0. So we can write like this, because this is 1. So it can be written like this, M0, L0, T0. Whenever a quantity is having this kind of dimensions, that is all the dimensions that are included, they are having a power 0, then the quantity is known as dimensionless. So angle is dimensionless. It means it is having a dimension as M0, L0, T0. It means no dimensions are there. All right. So we can say like this, that it is dimensionless. Angle is dimensionless. Okay. And there is one more quantity that is related to angle when we will be learning about the angular velocity or the angular acceleration in chapter number 7. We will be dealing with these things. Then one quantity will be there that is known as angular displacement. That is the angle swept by a body while traveling circular distance. That is known as angular displacement. And that angular displacement is denoted by the angle theta. All right. So that angular displacement is a quantity that is also dimensionless. You can see. So there is a quantity known as angular displacement, which is also denoted by theta. And that quantity has the same dimensions as the dimensions of this angle. That is M0, L0, T0. And whenever a quantity has this kind of dimensions, then it is known as dimensionless. All right. Whenever this kind of quantity occurs, then it is having a dimension as m0, l0, t0. So you can see this, that angular displacement is one another quantity that is having a dimensions as m0, l0, t0. And whenever a quantity, all right, whenever a quantity that is having dimensions as m0, l0, and t0, it is known as dimensionless. Okay, Chaitanya wants me to repeat this thing up because his connection was lost. So let me repeat it again once again. So we are actually doing what we are trying to find out the dimensional formula, all right, for different quantities. And first I have taken the angular quantities. In this, the first quantity is angle theta. It is given by this formula. Angle is given by this formula, arc length upon radius. Arc length has dimension L. Why so? Because it is some kind of length, and radius is also some kind of length. That's why it has also be having dimension as L. When you solve it out, L gets cancelled out with this L and you are left with 1. So this 1 can be written in terms of dimensions as m0, l0, t0, because no dimensions are there. All the numerical constants, they have the dimension as m0, l0, t0. No dimensions of mass, length, or times are involved in the numerical constants. Physical constants may have some dimensions, but numerical constants, they do not have any dimensions. And whenever a quantity is having such type of dimensions, then it is known as dimensionless. We say that this quantity is dimensionless. All right. Similarly, we are having another quantity that is known as angular displacement. That is the area or the angle swept by a body when it is doing some circular motion. When the body is in circular motion, the angle swept by it is known as angular displacement. And that angular displacement is also denoted by this theta, and it has dimensions m0, l0, t0, and this angular displacement is also dimensionless. All right. Now let's move towards the second quantity, that is angular velocity, and it is denoted by omega. This sign is omega. It is not W. All right. It is omega. When Greek symbols we use to describe these quantities like theta, omega, or alpha, beta, gamma. This is angular velocity denoted by omega. Angular velocity is angular displacement upon time. So the formula, we can write it like this. The angular velocity is equal to angular displacement upon time. We need to find the dimensions for angular velocity. So what we will be doing? First, we need to write the dimensions of angular displacement and then divide it with the dimensions of the time. Angular displacement is dimensionless. That is having a dimension m0, l0, t0. So in place of this, I can write it like this. Angular displacement is m0, l0, t0. And for time, the dimensions is capital T. All right. When you solve it out, this t, when it goes in the numerator, it becomes minus power. The power becomes minus for this t. And you can write it like this. m0, l0, t minus 1. And now you can easily write like this, that the dimensions for angular velocity is m0, l0, t minus 1. All right. Very simple. Angular velocity is angular displacement upon time. And you can write it like m0, l0, t0 upon t, and then solve it out. This is the dimensions for angular velocity. You need to remember this final result actually. See, the velocity is different from angular velocity. All right. The dimensions for velocity is what? Lt minus 1. But for angular velocity, it is m0, l0, t minus 1. So here L is not having any dimensions. But in case of velocity, we are having one dimension of L also, that is Lt minus 1. All right. Again, another quantity is there that is known as angular acceleration, and that is equal to angular velocity upon time. All right. So angular acceleration is angular velocity upon time. So we need to find the dimensions for angular acceleration. How we can do that? First, write the dimensions of angular velocity and then divide it with the dimensions of time. So we have just found out this thing, that the dimensions for angular velocity is m0, l0, t minus 1. So in place of numerator, we can write the dimensions like this, and the denominator is having a dimensions of time. Now when this denominator is when it will go in the numerator, it will add up one power to the t, that is minus power to t will be added up. So it becomes m0 l0 t minus 2. So you can write it like this, m0 l0 t minus 2, and then finally the final expression comes out. The dimensions for angular acceleration is m0 l0 t minus 2. All right, and this angular acceleration, it is denoted by alpha. The symbol for this angular acceleration is alpha. All right, and this is omega, the symbol for angular velocity. I hope these three things are very much clear to you. Still, if you are having some problem, please ask. I'm waiting for a while. So the next quantity that we have to derive the formula, that is the angular formula. Let's move towards that one. And that is torque. This is also denoted by a symbol tau, T-A-U. This symbol is tau, T-A-U. All right, tau. So this torque, it is denoted by symbol tau, and the formula for torque is force multiplied by perpendicular distance between the line of action. All right, this torque we will be learning up in chapter number 7, rotational dynamics. When we'll be doing that, then we will be learning that what is torque. The formula for this torque I have given to you because you will be needing the dimensional formula, and it will be very easy for you to calculate if you are knowing the formula. So the force multiplied by perpendicular distance. So force, write the dimension of force, that is MLT minus 2. All right, and the dimension for distance between the line of action. So it is some kind of distance. Distance is having dimension as L. So you can write it like this as L. All right. Now it becomes ML2 T minus 2. So you can write the dimensional formula for torque is ML2 T minus 2. All right. And you can see this, that this dimensional formula is similar to the dimensional formula of work as well as to of energy. So I've told you that there may be some various quantities which are having same dimensional formula. All right. This torque is one another quantity that is having dimensional formula similar to those of energy and work. All right. Is it fine or not? I do believe that you have got it. So just I have written it over here that energy is also having the same dimensional formula as that of torque as well as the work. Fine. Now we have to find the dimensional formula of some physical constants, and these physical constants we will be using them a lot in the applications questions that we'll be doing just after deriving these formulas. All right. So some physical constants. The first physical constant whose dimensional formula that we need to derive is universal gravitational constant, capital G, that is denoted by capital G. All right. And you have studied about this in the first chapter as well as in your class 9th, that what is universal gravitational constant. So the force between the two bodies of mass m1 and m2 in this universe is given by this formula, F equal to G m1 m2 upon r square, where G is your universal gravitational constant. In order to find the formula for G, we need to write the equation like this, that G is equal to something. All right. So take G into one side and all the other quantities to the another side, so that we can find the dimension for this G. So this implies this, that G is equal to F r square upon m1 m2. When you cross multiply it, cross multiply F with r square, and m1 m2 you put in denominator of this. So you got the formula like F r square upon m1 m2. Let me take a question from Isha. Yes, Isha, what you want to ask? Please go ahead with your question. Okay, she is saying that by mistake she has raised the hand. Okay, please, beta, take care of this thing. I'm very particular in seeing all those hands and your chat. All right. So please don't disturb the class in between if you don't want to ask anything. Please take care of that. Now moving towards this, G is equal to F r square upon m1 m2. All right. In order to find the dimensional formula for G, we need to find the dimensional formula for, we need to write the dimensional formula for F and then r square, and then divide it with the dimensional formula for m1 and m2. So you can write it like this. The dimensional formula for force is MLT minus 2. For r square, that is radius square, it is L square. 1 R stands for L, then L to the power 2 is L square, and then M1 and M2, they are having the dimensional formula as M multiplied by M, capital M, that is M square. So this is how you can find the dimensional formula for G. Now, just do the math, take this M square to the numerator, then it will become -2 and -2, and 1 plus 1 is already over there. You can write it like this. All right, that is M minus 1 L3 T minus 2. So in final expression, you can write the dimensional formula for G, that is universal gravitational constant, is M minus 1 L3 T minus 2. All right. So this is how we can find the dimensional formula for universal gravitational constant. All right. Let's take another example of some, we are talking about the physical constants. One physical constant is there that is known as specific heat capacity. All right. I hope that you have written it. If you still want some time, I can stop here for 10-15 seconds. We need to find the dimensional formula for specific heat capacity. And this specific heat capacity is a constant that is denoted by capital C. So first, people should know that by which formula we can find out this specific heat capacity. For this, we have one formula as Q is equal to mc delta T, where Q is the heat given, m is the mass, m is this mass, and delta T is the change in temperature. All right. So the heat given to a body is given by this formula, that is mc delta T, where small m is the mass, capital C is the specific heat capacity, and delta T is the change in temperature. Now, in order to find this C, we have to write the formula as C is equal to something. All right. So take all the other quantities to the other side, and you have to write it like C equal to. So we can write it like this. C is equal to Q upon M delta T. All right. So C, it becomes equal to Q upon M delta T. From this equation, we have written it. Now write the dimensional formulas for all the quantities that are towards the right hand side. So heat is a form of energy. So the dimensional formula for energy has to be the dimensional formula for Q. So that is equal to mL2 T minus 2. So now in order to find this thing up, you people should know this, that is what is the dimensional formula for Q, and that we have done in our previous class. The dimensional formula for work and energy we have obtained over there. So also you can write it from here, because torque, energy and work, they have the same dimensional formula. So it is mL2 T minus 2. Dimensional formula for this mass M, it is capital M. For small m, the mass, the dimensional formula will be capital M. And the dimensional formula for this temperature is capital K. It is not time. It is not time, beta. It is temperature. And for time, we are having capital K. So please put those things. You can write it like this: mL2 T minus 2 upon M and K. This K is for Kelvin. So this, from Kelvin, we have got this dimensional formula of temperature, capital T. All right. It is not time. So this M gets cancelled out with this M. You can write it like this: M0 L2 T minus 2 K minus 1. All right. And then the dimensional formula for C, finally we can write it like this. The dimensional formula for C is M0 L2 T minus 2 K minus 1. So this is how we can find the dimensional formula for a constant that is known as specific heat capacity. All right. All these terms we will be learning up. All right. So this formula we will be deriving when we'll be going through chapter number 10 or 11. All right. Someone has put some, sir, please tell from where we got very first equation. So this I'll be telling you when we'll be dealing up from the thermal properties of matter. All right. And the properties of fluids that we'll be dealing, then we'll be learning about this, that how we have got this equation. All right. That why this Q is equal to mc delta T. Fine, Varsha. I hope that I'm very much clear that this first equation, we will be learning about these equations. Now we have to just remember of the formula so that we can find the dimensional formula. All right. And then also Herman has raised hand. So let me ask Herman that what he wants to know from me. All right. Okay. Herman, what you want to say, beta? Please go ahead with your question. Yes, Herman, can you listen? Go ahead with your question. Now, moving towards the third physical constant. The third physical constant is a gas constant. So when we'll be learning about the properties of fluids, and when we will be going through the kinetic theory, that is chapter number 13, then we will be learning this equation, the ideal gas equation, that is PV is equal to nRT. All right. And now we have to just remember it up in order to find the dimensional formula for R. So here P is pressure, V is volume, N is number of moles, R is gas constant, and T is temperature. All right. So this is how the ideal gas equation related, PV equal to nRT, where all these five quantities, I've written it over here for you, that what these five quantities are. Now we have to find the dimensional formula for the gas constant capital R. So we can do it like this. First, we need to write the equation in terms of R, that we have to write it like R is equal to something. All right. And then it becomes like this, R is equal to PV upon NT. Then write the dimensional formula for P, that is pressure. Write the dimensional formula for V, that is volume. Write the dimensional formula for number of moles N, and the temperature T. So you can write it like this. Pressure can be written as M L minus 1 T minus 2. Volume, it is L cubed, length multiplied by breadth multiplied by height. All the three are, they were having dimensions of length only. So volume is L cubed. And N, number of moles, it has the dimensional symbol as MOL. And temperature, it is having a dimensional symbol as capital K. Now when you solve it out, this mole and capital K, it goes into the numerator, and the equation becomes like this. After solving this L minus 1 with this L cube, it becomes L to the power 2, and T minus 2 remains as it is. Mole, it becomes mole inverse, and K, it becomes K inverse when it go in the numerator. So you are left with this thing. Now that we can write dimensional formula for gas constant R is equal to ML2 T minus 2 mole inverse K inverse. All right. So this is how we can find the dimensional formula for a gas constant, that is R. Now again, we need to find the dimensional formula, and the next physical constant is Planck's constant. It is denoted by H. All right. So this Planck's constant you will be learning in your chemistry also, when you will be going through the photoelectric effect, and this you also be learning in class 12th, when you will be going through the atoms and nuclei as well as the dual nature of radiation. All right. So this is Planck's constant. The energy is related to the frequency in this manner. E is equal to H nu, where E stands for energy, H is your Planck's constant, and it is nu, it is your frequency. All right. So here I have written it. E is energy, nu is frequency, and H is Planck's constant. We need to find the dimensional formula for Planck's constant. So write it in terms of H. H is equal to E by nu. You can write it like this. Take this nu in the denominator to the other side and H towards one side. Then write the dimensional formula for E and nu. The dimensional formula for E is ML2 T minus 2. Energy and the work, they are having the same dimensional formula. And the dimensional formula for frequency is T minus 1. We know this. When this T minus 1, it will go in the numerator, it becomes plus 1. And that plus 1 with this minus 2, it makes it this minus as minus 1. So you'll be left with ML2 T minus 1. All right. So finally, you can write the dimensional formula for Planck's constant H is equal to ML2 T minus 1. All right. So very simple. Now you people are in a habit to find these things out. So you can easily find out if you are knowing the formula in which the physical constants are involved. One more constant is there, that is coefficient of viscosity, and it is denoted by symbol eta. This symbol is eta, ETA. All right. The Greek symbol. Let me write it for you people. What this symbol is known as, and this symbol is eta. All right. So you call it as eta. This symbol is that. All right. This is eta. So let's try to find out the dimensional formula for eta. But for that, we have to know some formula in which this eta is there. So you can say that there is something for a spherical ball of radius r moving with velocity v in a viscous fluid, the viscous force F on it is given by this formula, that F is equal to 6 pi eta RV. This formula we will be deriving when we will be doing chapter number 10. That is the properties of fluids. All right. So when we will be doing with the mechanical properties of the fluids, we will be deriving this formula over there. For now, you have to remember this formula only, that F is equal to 6 pi eta RV, where F is the viscous force, R is the radius, and V is the velocity, and eta is the coefficient of viscosity. All right. So from this formula, we can write eta is equal to F upon 6 pi RV. So you can write it like this. Eta is equal to F upon 6 pi RV, where R is your radius, V is your velocity, F is your force. Viscous force is a kind of force only. In order to find the dimensions of coefficient of viscosity eta, you have to write the dimensions for all the quantities towards the right hand side. So for force, you can write mLT minus 2. 6 is a numerical constant. It do not have any dimension. Pi is also a numerical constant. Its value is 3.14. So it do not have any dimensions. So for these 6 pi, you can drop up the dimensions because they are dimensionless. And for R, you can write L. For V, you can write LT minus 1. So it becomes like this. M L1 T minus 2 upon L. 1L is for this R. And for V, you have write LT minus 1. Okay, you have written it LT minus 1 for V. And for this R, you have written L. Now trying to solve it out. 1L gets cancelled out with 1L. 1L will go in the numerator. And this T minus 1, when it go to the numerator, it becomes plus. So again, it makes this minus 2 as minus 1. So you are left with this. M L minus 1, T minus 1. All right. And then the dimensions for eta is M L minus 1, T minus 1. So these are the dimensions for eta. Very simple to do that. Just you have to remember the formula. If you remember the formula, write the equation in terms of the physical constant, then put up the dimensional formula of all the quantities towards the right hand side, solve those things and find out the dimensional formula for the physical constant. This is how the procedure works. All right. I hope this is clear. And still, if you are having some problem, you can ask your doubts anytime. All right, then moving towards next. There are some more important quantities whose dimensional formula you should know, and we will be using them in the questions to come. So please solve it along with me. One is pressure gradient. So this pressure gradient, it is pressure per unit length. It is pressure per unit length. It means pressure divided by length. All right. So in order to find the dimensional formula for pressure gradient, what we should be doing? Write the formula for pressure and then divide it with the dimensional formula of length. So you can say, see it, that the dimensional formula for pressure is ml minus 1 t minus 2, and for length it is L. Easily you can cancel it out and it becomes ml minus 2 t minus 2. So finally you can write the dimensional formula for pressure gradient is ml minus 2 t minus 2. All right. So it is quite simple. Now you people are easily be doing it because you are in the momentum to do that. All set because you have learned it out. So many times I have derived the dimensional formula. So I'll be a bit quick in this one. Then there is one constant that is known as Young's modulus, and it is denoted by capital Y. This Young's modulus is denoted by capital Y. And when we will be learning about the mechanical properties of the solid in chapter 9, then we will be dealing up with this Young's modulus. The formula for this Young's modulus is this: F upon A divided by delta L upon L, where F is your force A is your area, delta L is change in length, and small l is length, original length. All right. So this is how the Young's modulus is related to these quantities. So we can write in order to find the dimensional formula for this Y, we have to write the dimensional formula for all the quantities that are involved. So for force, it is MLT minus 2. For area, it is L square. For delta L, that is change in length will also be some type of length. So it is L. And again for length, it is L. So the denominator gets cancelled out. They are not having any dimensions because delta L upon L is some length upon length that will be having no dimensions. And then this formula ML1 T minus 2, when you solve it out in the numerator, you are left with this ML minus 1 T minus 2. All right. And then finally, you can write the dimensional formula for Young's modulus is ML minus 1 T minus 2. And you can see it that this dimensional formula is also the dimensional formula for pressure. So the Young's modulus, it has the same dimensional formula as the pressure. All right. That is ML minus 1 T minus 2. Now, very quickly move towards another important quantity that is known as surface tension. This surface tension is denoted by sigma, and it is force per unit length. All right. It is not pressure per unit length, but it is force per unit length. Pressure per unit length is pressure gradient that we have done in part 1. All right. The first part of these important quantities, that is pressure gradient. Now we have to do for surface tension, that is sigma is equal to F upon L. All right. Now here F is force, L is length. Easily you can do it. ML1 T minus 2. All right. Or you can write ML T minus 2 upon L. This L gets cancelled out with this L. You are left with MT minus 2. So finally, you can write the dimensional formula for surface tension is ML0 T minus 2, because this L gets cancelled out with this L. All right. Then we have another quantity that is known as Boltzmann's constant, and it is denoted by small k. The formula for Boltzmann constant is heat upon temperature. All right. So this is the formula for Boltzmann constant. That is heat upon temperature. Heat is some form of energy, and energy is having dimensional formula as ML2 T minus 2. And temperature, it is having dimensional formula as K, that is from Kelvin K. It is not having T. T is for time. All right. So you can, when you solve this equation, this K will go into the numerator, and you are left with ML2 T minus 2 K minus 1. All right. So this is the final expression for the Boltzmann constant dimensional formula, that is ML2 T minus 2 K minus 1. All right. So this is all that I want to tell you about the dimensional formula. Some other important dimensional formula that we will be needing during the applications of the dimensions, that we will be deriving at that time only. At least this you people should know. Okay. And you have to learn these final results. Once you will be in a habit of using them in the questions, you will be easily learning them up. Now we have to move towards the applications of dimensions, and only one application I'll be covering up today. Okay. And then we are having some more applications to do. All right. So there are actually 3 or 4 applications of this dimensional analysis. We have to do all the applications, but first I'll be doing the dimensional dimensional analysis application, that is applications of dimensions. And in this, we have to find the dimensions of unknown quantity in the equation. This is the first application. All right. That we can use the dimensions to find the dimensions of some unknown quantities that are present in the equation. All right. And for that, we have to learn about some rules, the working rules. All right. So if we know these working rules, we can easily be doing the analysis by using the dimensional formula to find the unknown quantities dimensions that are involved in the equation. All right. So that we can easily do. The first working rule is this one, that similar quantities can be added or subtracted to or from similar quantities, and the operation will result in the same quantity. All right, and the operation will result in the same quantity. You have to know this, that what I want to say when I say this thing, that similar quantities can be added to similar quantities, or similar quantities can be subtracted from similar quantities, and the operation of addition and subtraction will result in the same quantity. For example, you can add velocity to velocity. You cannot add force to velocity. Is it possible to add force to velocity? You can add distance to distance. Is it possible to add distance to some velocity, or is it possible to subtract velocity from some distance? You can only add or subtract similar quantities. And if you add two velocity, the result will be velocity. If you add two forces, the result will be force. If you add two lengths, the result will also be another length. If you subtract two velocities, obviously you will be getting some velocity. All right. So this is rule one, that only similar quantities can be added to similar quantities, or similar quantities can be subtracted from similar quantities, and the operation will result in the same quantity. For example, if I perform an operation like length plus alpha, alpha is some quantity, then the dimension of alpha has to be equal to the dimension of length. All right, or not? Because only similar quantities can be added to similar quantities. So this alpha, whatever be this alpha, it must have a dimension that is equal to the dimension of length. All right. Also, if we perform an operation such as force minus beta, where F is force, F minus beta we are doing, then beta should have dimensions that are the dimensions of force. All right, because this beta is being subtracted from force, it can only be done when beta has the same dimensions as that of force. I've told you only similar quantities can be subtracted from similar quantities, and whatever be the result of this, if it is equal to, say for example, gamma, then gamma must have the same dimension of force. Why so? Because when you subtract it out, you will be getting some dimensions. You will be getting a quantity that is having dimension of force only, and that is equal to gamma. If it is equal to gamma, then gamma must have a dimension of F minus beta, that is dimension of force only. All right. So the result of this quantity will also be the same quantity. If you perform addition or subtraction of two quantities, then you will be getting the same quantity. In terms of dimensions, I'm talking actually. All right. Then rule 2, if theta is dimensionless, we know this, we have derived it, angle theta is dimensionless, then sine of theta is also dimensionless, because you know sine 30 is having some numerical value. The value of sine 30 is half, sine 45 is 1 by root 2. All these are dimensionless. So theta is dimensionless. Also sine theta is dimensionless. In fact, we can say this, whatever be the trigonometric ratios, all right, sine, cos, tan, etc., with suitable argument theta, they are dimensionless. They have dimension as m0, l0, t0. All right. So the dimension of whatever be the quantity inside the brackets of sine will be m0, l0, t0. If I write in place of this theta, if I write alpha, t, square, v, r, so whatever be the quantity inside it, it must have a dimension of m0, l0, t0. All right. Collectively, that quantity must be dimensionless. Also, if e to the power x is given, then it has to be dimensionless. Exponential function is dimensional. Log function is also dimensionless. That is, they have dimension as m0, l0, t0. Fine. So these three rules we will be using to solve up the questions that are following this one. So some examples I have solved for you. Please try to solve those examples along with me. Okay. I hope that it is clear. If still you are having some doubt, please raise hand or write your doubts in the chat. Then only I'll be moving towards the examples. Only 3 examples we need to do today. And then I'm giving you some homework exercise that you have to submit and mail it. Okay. Okay, no problem is there. So let me resume the explanation. Okay, Varsha, are you able to listen? There may be some problem in your internet connection, I think. Please respond if you are able to listen. Then only I'll be explaining it again. Varsha, please respond. Okay, fine. Okay, you are getting my voice. Now I'll be explaining it again. Fine. Yes, anyone wants to ask something, please ask. Let me ask you the doubts. But, let me talk to you also. I also want to talk to a lot of people actually. Talking is really very good thing. Okay, let me talk to. Okay, let me talk to some people who must be waiting over there. Okay, fine. Okay. Okay, Gargi is there. Let me talk to Gargi. She has joined in very long time actually. Why she is not joined? Hello. 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 Gargi, are you able to listen?
Yes, sir.
So, Beta, why you have joined so late?
Sir, the mobile has no recharge of network internet.
So Beta, you could have asked me, na? I have done it for you. Okay, please try to, Beta, this is the only thing actually that how we can be reaching to you people in this pandemic situation. We can only be reaching you by this medium. So I know that it's a bit costly or something, but this is what we are left with actually. We are not having any choices, isn't it?
Yes, sir.
Fine then. And you written all the notes and all that?
Sir, I have taken screenshot.
No screenshots should be there. Beta, I'll be sending you the PDF na. So okay, just
Okay,
practice it. And then the PDFs will be, I'm not saying the previous notes, previous lecture notes, have you written it in the copy or not?
no, sir.
Please write it down. Okay?
Yes, sir.
Yeah, please write it down. Okay, let me talk to Lipika also. Lipika is there. Let's talk to Paki. Hello, Paki, how are you? Let me talk to Paki. How are you, beta? Okay, she don't want to talk. She just mutes her mobile all the time. Hello?
Yes, sir.
Yeah, Lipika, have you got, good morning. Have you got that lecture 4?
Yes, sir.
Okay, fine. Then those who are not getting it, try to be in touch with them and share it among your friends also. All right?
Okay, sir.
All right.
Yes, sir.
Okay, Paki is saying that she is muted. So let me unmute her. Yeah, yeah. Why you are getting muted all the time?
Hello, sir.
Yeah, beta, I am able to listen. Go ahead. How are you?
Fine, sir.
Okay, beta, are you writing up the thing?
Sir, I am actually learning these things.
हाँ बेटा लिख लो इनको मतलब क्या इनको सीखो भी और कॉपी में लिख भी लेना क्योंकि मैं चेक करूंगा जब आऊंगा जब स्कूल ठीक है ना
Yes, sir.
Fine. Okay, one question from the last chapter. Okay, Shreya, go ahead with your question. Let me unmute you. Okay, nice to talk to you, Paki. Okay, she got the answer also. Varsha got the answer also. She has solved it. Very good. You are getting it now. Wow. Very good. Okay, let me talk to Shreya. Yeah, Shreya. Yeah, Shreya, go ahead with your question.
सर आई वाज स्टडिंग द लास्ट चैप्टर, तो उसमें अपन ने पढ़ा था कि 4 फोर्सेस होती है मेनली,
हाँ बेटा,
ग्रेविटेशनल, इलेक्ट्रोस्टैटिक, वीक न्यूक्लियस और स्ट्रॉन्ग न्यूक्लियस। तो सर एक बात
इलेक्ट्रोमैग्नेटिक।
बताइए, हाँ, तो सर जैसे कि मैंने किसी को धक्का दिया, मस्कुलर फोर्स, एनीथिंग एल्स, तो वो
हाँ
सब कहाँ जाएंगे?
बेटा, दैट डिपेंड्स ऑन दीज 4 फोर्सेस। ग्रेविटेशनल फोर्स पे डिपेंड करता है तुम्हारा मस्कुलर फोर्स, ठीक है। द इंटेंसिटी ऑफ दीज फोर्सेस इट डिपेंड्स ऑन द ग्रेविटेशनल फोर्स। तुम अगर चांद पे जाओगे, किसी को उतना ही धक्का दे सकते हो क्या?
नहीं सर।
हाँ, तो ग्रेविटी पे डिपेंड करता है बेटा, है ना। तो मस्कुलर फोर्स, स्प्रिंग
तो
फोर्स, ये
हमारी
सारे
बाकी वाली फोर्सेस?
लगभग बहुत सारे फोर्स तो ग्रेविटी पे डिपेंड करते हैं, ठीक है। स्प्रिंग फोर्स
ओके।
हुआ, ये सब, ये सारे बहुत सारे फोर्स तो ग्रेविटी पे डिपेंड करते हैं। ये डिराइव होके आते हैं यहीं से, ठीक है। फ्रिक्शनल फोर्स है वो तुम्हारा सरफेस के उस पे स्ट्रक्चर पे डिपेंड करता है, वो एटॉमिक स्ट्रक्चर पे डिपेंड करता है। तो तुम्हारा न्यूक्लियर, उनके एटॉमिक स्ट्रक्चर और इन सब पे डिपेंड करता है, और वो डिपेंड करते हैं तुम्हारे न्यूक्लियर फोर्स पे फाइनली, ठीक है। वो एक
थैंक यू
दूसरे से
सर।
डिराइव होके आते हैं बेटा, ठीक है। फाइन, ओके
ओके,
ओके
थैंक यू
बेटा,
सर।
ओके। Anyone else? Anshika is there, Gargi is there, Super Suryans is there. Okay, Super Suryans. Does this mean that spring will not work in outer space? It will work, but the intensity will change. It is not the case that it won't work, but we have to consider it. All right. Let me take some feedbacks from you people कि चल क्या रहा है, प्रोजेक्ट ठीक चल रही है कि नहीं चल रही है। मैं बात तो कर लूँ तुमसे, वर्षा से बात करेंगे हम। वर्षा चली गई है क्या? वर्षा हैज लेफ्ट। ओके, देन लेट मी टॉक टू वंशिका। वंशिका नूनिया आई हैं आज कई दिनों बाद क्लास में, उनसे बात कर लेते हैं। हेलो हेलो
Yes, sir.
हेलो बेटा, हाउ आर यू?
Good morning, sir.
मॉर्निंग। और बेटा कैसे हो?
Yes, sir.
तो
I'm fine.
हाँ, वो सब तो ठीक है बेटा। और तबीयत
Sir,
ठीक है?
I'm fine.
तबीयत ठीक है ना?
Yes,
हाँ
sir.
हाँ,
Yes,
वो
sir. Yes, sir.
बीच में एक बार बीमार हो गए थे बेटा।
हाँ,
ये समझ में आ रहा है क्या फिजिक्स में कुछ चल रहा है, या फिर सब ऐसे ही सर पढ़ा के चले जाते हैं, टाइम वेस्ट कर देते हैं सारा?
नहीं सर, आ रहा है, आ तो रहा है।
हाँ, तो इनको ढंग से पढ़ो बेटा, तभी जाएगा समझ में, और है ना। ऑल राइट, करो और मेहनत करो थोड़ी, ठीक है।
सर सुन रहे हो क्या?
हाँ बेटा, बोलो व्हाट यू वांट। हाँ
हाँ
बोलो
सर।
बेटा, बोलो बोलो बेटा, क्या क्या चाहते हो?
Yes, sir.
अच्छा, इफ यू पीपल हैव नॉट अटेंडेड द क्लासेस, वीडियो ले लेना।
क्या?
अगर पहले की क्लासेस नहीं ली हैं कुछ, तो यू कैन टेक अप द वीडियो लेक्चर ना, वो रिकॉर्डेड है पूरा, तो तुम वो ले सकते हो।
Sir,
और
are
वहां
you able to hear me?
या श्योर, आई एम एबल टू लिसन, आई एम लिसनिंग।
नहीं चाहते कुछ नहीं, लेकिन आपकी आवाज नहीं आ रही थी सर।
ओके फाइन फाइन, अभी आ रही है आवाज? Beta, if any one of you wants the video lecture or something, please contact me, okay? And then I'll be mailing it to you. All right. Thank you very much for joining. That's all for today. Thanks a lot. I'll be sending you this PDF very soon. Thank you.